Hello students, and welcome back to another lovely day of physical science. This is actually one of the best lessons of the year. Dimensional analysis, in my opinion, is possibly the most important skill that you will learn about in this class. It's going to be used in here a lot. It's going to be used when you get to 11th grade chemistry. It's going to be used when you get to 12th grade physics. And actually, it can be used a lot just in everyday life. It's an awesome skill, so let's get started learning about it. One thing that I do want to note, while this video lesson is a little long, it's also going through and showing all the steps on how to solve every one of these problems. I do start to just provide you the answer, and if you get it, great, you'll be able to go through the lesson a little bit quicker. If you need additional help, please take the time and watch through the video lesson. Today's learning outcome is that you will be able to convert between metric and English units using dimensional analysis. Keep in mind, today we're just getting into the basics of it. Dimensional analysis will get a little more complicated as we go on, but it becomes even more and more useful. But for now, let's learn how to convert from metric, such as meters, into English, such as feet or miles. Before we get too far into dimensional analysis, let's actually explain in a way that you already know how it works. So here, you could raise your hand, but you're watching a video lesson, so it's not going to do a whole lot. I can't really call on you. What I would like you to do is just think to yourself, do you know this answer, and do you know a simple way of solving for it? Take a minute, pause the video, and see what you get. So I'm going to tell you there are some very easy ways to solve for this one. Some of you may have gotten an answer of like 15 over 21, which is fine, but there's an even easier answer. And that answer is 5 over 7. The way that I would get that is if you have a 3 on top and a 3 on bottom, since these are multiplied, they basically just cancel each other out. Because really, it's the same as 3 over 3, which is equal to 1. And we know that anything multiplied by 1 is itself, so therefore, the answer is just 5 over 7. Let's try another one, a little bit more complicated. We're going to add in another set of numbers there. I want you to pause the video and see what answer you come up with for this one. Alright, easiest answer here is just 7 over 3. And that's because 9 on top cancels out 9 on bottom. 13 on top cancels 13 on bottom. So you're just left with an answer of 7 divided by 3. Ooh, let's try this one out. Here we have a super long, complicated problem, but there is a very, very simple answer. Pause the video and see what answer you can come up with. Alright, I hope you didn't have to plug that into your calculator because there's a very, very easy answer here, and that answer is 3 divided by 7. So the easiest way to do this is you see 15 on top is going to cancel out 15 on bottom. Again, notice they don't have to be side by side. As long as one is on top and one is on bottom, it doesn't matter how far apart they are on the number lines. So 50 on top, cancel out 50 on bottom. 23 on top, cancel out 23 on bottom. 68 cancels out 68. 121, cancel out 121. I have 3 on top. I don't have 3 on bottom though, so that doesn't cancel out. But 1,389 cancels out 1,389. So all I am left with is 3 divided by 7. This exact same concept is going to apply to dimensional analysis. The only difference is now we're going to be working with numbers and units, but just like numbers cancel out, units are going to cancel out as well. And here, we can even relate that same strategy to letters or to variables. So pause the video and see what answer you can come up with. Alright, and the answer for this one is going to be Z over W. X cancels out X, Y cancels out Y, and all you're left with is Z divided by W. So we use this idea of canceling or crossing things off to convert units, and what we call that process is dimensional analysis. So again, dimensional analysis sounds big and scary, but really, it's a pretty simple process. But this is going to require writing out your work. I cannot stress that enough. You need to show work when doing dimensional analysis. It's very important, it's very crucial. not just for the sake of me seeing what you're doing, but for the sake of you making sure you don't make a mistake, and you're going to see why that is and how easy it is to make a mistake as you're working through this. So with dimensional analysis problems, biggest hint is just don't try and rush through it. Take your time, do it properly. It's only going to add about 30 seconds of time, but it's going to guarantee you to get the correct answer. All right, let's go through and do our first ever dimensional analysis problem. So taking a look at this, we're going to see that we need to convert from 15 feet into inches. Well, this is a pretty straightforward conversion. This is actually going to be an English system to English system because feet and inches are both English. So taking a look at your new best friend, you will see this conversion that 12 inches is equal to 1 foot. So therefore we have a path, and you should always take the time to write out your path. We have a path going straight from feet into inches. And the reason that I have you write out a path, and I've taught dimensional analysis a lot of times, and I'm going to show the method that works for 95% of students. There's other ways to think through these problems, but this really guarantees students get a correct answer. So after you have written out your path here, you'll notice we have one arrow. Well, for every arrow that you have is a conversion that you need to pull from your new best friend, from that conversion sheet. And in this case, that conversion is going to be that there are 12 inches is equal to 1 foot. Well, really, that's the same as saying 12 inches per 1 foot, because notice these are the exact same thing. It doesn't matter which way I write it, they're the exact same thing. 12 inches per 1 foot or 1 foot per 12 inches, it doesn't really matter. So what we're going to do now is let's actually go through and solve this problem. So when you're doing dimensional analysis, first thing you need to do is take what you're given, what you are trying to convert. In this case, I want to know, well, 15 feet is equal to how many inches? So I'm going to take what is given to us, which is 15 feet, and I'm going to put that on top. Now what happens is we have to get rid of these units of feet because we don't want feet in our final answer. And I like to just think of this as building railroad tracks. So here, since I have one step or one conversion, I need one additional set of railroad tracks. And all you can ever do is pull in these conversions to build your railroad tracks. But you need to figure out which unit goes on top and which unit is going to go on bottom. Well, think back to what we just did in the notes. We don't want feet in our final answer. So how do we get rid of feet? We have to write feet on bottom. So what I'm going to do is I'm going to pull in my set of railroad tracks, that is, pull in my conversion, and I know that 1 foot is equal to 12 inches. And this is helpful because guess what? Feet on top cancel out feet on bottom. Just like 3 on top would cancel out 3 on bottom. And now what we're left with is this unit of inches, which is exactly what our goal was. So now what we need to do is take everything on top, so 15 times 12, so that's how you're going to do these problems, is you take everything on top, divide it by everything on the bottom. So when I take 15 times 12, we're going to get an answer of 180. And notice, feet cancel out. We don't have units of feet anymore, but we do still have units of inches. So that gets us into 180 inches, and we could divide by 1, but remember, anything divided by 1 is just itself. So there we go. We have officially solved our first ever dimensional analysis problem. If you're confused, don't worry, there's going to be plenty of more practice in the upcoming slides. Alright, let's just keep the fun train rolling here, and we see that we're going to convert 100 grams, and we need to know how many ounces is that. In this case, grams are a metric unit, ounces are an English unit, so we need to look at our new best friend, and we see that 28.35 grams is equal to 1 ounce. Well, in that case, that means that we have a path to go straight from grams into ounces. So that's telling me that we're going to need to write one conversion out. And that conversion in this case is telling us 28 28.35 grams is equal to 1 ounce. And again, it doesn't matter what goes on top or what goes on bottom. 28.35 grams is the same as 1 ounce. And I could write that the other way, 1 ounce per 28.35 grams. It doesn't matter. They're the exact same thing. So a lot of times I'm just going to write it out just like this, where 28.35 grams equals 1 ounce, and we'll figure out what needs to go on top or bottom as we're building our railroad tracks. So we take what we're given, which is 100 grams. That is whatever we want to convert is our given. We're going to need one set of tracks again because we only have one conversion. We only have one arrow. And now we need to figure out, well, what unit goes on top? What unit goes on bottom? Since I have grams on top, I don't want grams in my final answer. So we need grams to cancel out. And in order to do that, I'm going to write 28.35 grams, and that was equal to 1 ounce. Grams on top, cancel out grams on bottom, and we are left with our desired units of ounces. So now what we need to do is take everything on top and multiply it, and then divide it by everything on bottom. In this case, we're just going to get 100 times 1, which is 100, divided by our 28.35, and that is going to give us a final answer of 3.52, and then we have to bring in our units, so 3.52 ounces. And that is going to be our final answer. So therefore, we know that 100 grams is equal to 3.52 ounces. All right, let's start picking up the speed a little bit. So here, we have 50 inches, and we want to know how many millimeters is that equal to. So we need to figure out a path, and we notice that we are going from an English unit to a metric unit. So therefore, we're going to look at this part of our conversion sheet, and we're going to notice we don't have a conversion going straight from inches into millimeters. What we do have, though, is we have a conversion from inches into centimeters. And then we can look at our other side of the conversion sheet and see that there is 1 centimeter is equal to 10 millimeters. Or you could have also used your number line. So in this case, we need to figure out our path, and our path is going to look different than it has before. Now we're going to be converting from units of inches. We can't go straight to millimeters. We're going to convert from inches into centimeters, and then from centimeters into millimeters. So what this means now is we're actually going to need 2 different conversions. So our first conversion, which is going to be our first set of railroad tracks, is going to be 1 inch is equal to 2.54 centimeters. Our second conversion is that 1 centimeter is equal to 10 millimeters. So now we go ahead and start the problem, and we are going to have 50 inches as our given, so as what we're starting with, and then I'm just going to go ahead and pre-build my railroad tracks. Again, I know that in this case I'm going to need 2 additional set of tracks because I have 2 conversions. And I notice I have inches starting, but I only want to end up with millimeters, so we need to get inches to cancel out. So taking a look at our first conversion here, I need to put inches on bottom, so that is 1 inch was equal to 2.54 centimeters. So therefore, inches on top, cancel out inches on bottom. If I stopped my conversion right now, we would have converted inches into centimeters, but that's not what we want, so we have to carry on. In this case, I can almost just cross out that conversion. I've used it already. I'm on to my second conversion, that is my second set of tracks. So what I need to do now is I need centimeters to cancel out, and I have to get to millimeters. So therefore 1 centimeter is equal to 10 millimeters. Centimeters on top, cancel out centimeters on bottom, and hey, look at that, we got to our desired units of millimeters. So now what I'm going to do is multiply everything on top and then divide it by everything on bottom, which in this case again is just 1. So now in my calculator, I'm going to take 50 times 2.54 times 10 and get an answer of 1,270 millimeters. And now I know that 50 inches is equal to 1,270 millimeters.